if I remember correctly, we have 2 proofs left. So we were looking at proving triangles are congruent by side, 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 and side angle side. And so we had looked at 2 proofs already, and then we had 2 more to look at, one that's kind of short and then one that's a little bit longer. So the next proof, it says to use a paragraph proof, but as I've said, we're not doing that, so I'm modifying number 24. And when you do 23, like, it'll be the same thing, but it's modified. We're going to do a 2-column proof. The given is that PT is congruent to RT and QT is congruent to ST. And we're proving that triangle PQT is congruent to triangle RST. And then they also give us a picture. It's more like a sideways rectangle, I guess. Okay, so I can draw it sideways. Good enough. That was really bad. Okay. Just, these are triangles, okay? P, Q, R, and S. This middle one is T. And then this one. All right, so that's the given information right there. They've given you a picture, which, as I've said before, can be classified as given information as well. And then obviously whatever they tell you, but what I've marked is all of this was like given. I didn't do anything extra based on the information that I had. All right, so we're going to set this up as our 2-column proof. All right, so first thing is going to be our given information. So PT is congruent to RT and QT is congruent to ST. Now, ultimately, I'm trying to prove that these triangles are congruent. So I either need to prove that, according to what I know up to this point, that all 3 sides of both are congruent, or that I have a side, an angle, and another side. And I'm trying to prove PQT, so that's this triangle right here, is congruent to RST, so that's this triangle right here. Okay? So, knowing that's going to help us, because there's a lot of things I can say about this, like, picture that I'm given, but I only need what I'm actually trying to find. So, the other option besides side, 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 because I have no way with the information that I have to prove that the 2 sides would be congruent, or this third side is congruent, I want to see if I can prove that this angle is congruent to this one so that I would have a side angle side situation. Is there a way that I can show that those 2 angles are congruent? Yep, the vertical angles theorem. So we would say that angle QTP is congruent to angle RTS. Some combination of that. It could be PTQ or STR. As long as the T is in the middle, it's fine. And that is by the vertical angles theorem. And so then, now I know that this angle is congruent to this angle. And so, I can now say that my 2 triangles are congruent. So triangle PQT is congruent to triangle RST by side angle side. For the angle. Yeah. For the triangle, as long as the letters go in the same order, like with the stuff that's congruent, you're fine. What else was I going to say about this? They could have also asked us to prove that triangle RTQ was congruent to triangle PTS, and that would have been doing the same thing, but we would have been using these two instead of the two that we had. But we just were going with obviously what they asked us for, but just so that you're aware, we could also prove that these two triangles over here are congruent using the same method of vertical angles for those two.
That's it, right?
Yeah, that's it for this one. All right, the last proof, they tell you that you have the option of using a 2-column proof or a paragraph proof, but we're not ever writing paragraph proofs. So we're using the 2-column proof option. So number 26, we've, let's see, given, there's several things here. BC is congruent to AE. BD is congruent to AD. And DE is congruent to DC. And we're trying to prove that triangle ABC is congruent to triangle BAE. And I'll draw our picture here. All right, so that's what our picture looks like there. So just this side is not filled in, basically. All right, so ultimately, I'm trying to prove that this big triangle here, ABC, is congruent to this triangle here, BAE. Okay, so these two overlapping triangles, I'm trying to prove that they are congruent. So this picture doesn't like show us the stuff that's congruent. So I like to, even before I start my proof, if they don't already mark the stuff up for me, I like to go and fill that in because, as you've been told many times, I'm a visual person, so I like to see it. So I know that BC is congruent to AE, so I'm going to put my markings on that. I know that BD is congruent to AD, so that's these ones. And I know that DE is congruent to DC. So I've got all of those things marked now. So I'm going to set up my proof. Like I said, this one's going to be a little bit longer because there's just a lot to this one that's going to kind of combine everything we've been doing in all of our units so far, with different rules and theorems and things. All right, so I'm going to start with all of my given information in one thing. So BC congruent to AE, BD congruent to AD, and DE congruent to DC, with the reason of that being a given piece of information. So if two segments are congruent, what else do we know is true about them? About their measures? They're equal to each other. So I would probably go with something like not so much AE and BC. I really don't need those. But if we notice, I have these two are congruent and these two are congruent. So most likely, since I'm trying to prove this whole triangle here, I'm going to need something that says that these, like this whole side is congruent to this whole side. So I'm going to do something that talks about the measures of these two sides here. So in this next step, again, I'm going to do it all in one. I'm going to say that AD is equal to BD, talking about their measures. And that DE is equal to DC. So remember, when we say the segments are congruent, we can also say that they're equal, and that's the definition of congruent segments. And a lot of times if you're checking your answers in the book, they're just going to abbreviate segment like SEG. If you want to write the whole word out, be my guest. So next, like I said, I ultimately am pretty sure I'm going to need to show that this whole side right here and this whole side are obviously going to end up having to be congruent to prove my triangles are congruent. So what can I do with this side right here based on what I have so far? Any guesses? Like if you ignore everything else about this shape. That deals with angles. I know it's covering up, so it's darkening it. But what would be true about that line? What would be true about BD and DE? How about that BD plus DE has to be equal to this because both of the pieces are congruent. I have that there's a congruent here, and I have that these are congruent, so if I add them together, then I can say that they're equal to each other. So BD and DE is equal to AD and DC. And I can do that with addition. Now, what's true about this altogether then? Like if I just am looking at BD plus DE, what does that equal to? Yep, BD plus DE equals BE. And then I can do the same with this other one. I can say that AD plus DC is equal to AC. What allows me to do that? Has a special name. It's a postulate. What are each of these pieces called? Segment, and I'm adding them. Segment addition postulate. Now, I could also swap these two steps. It really doesn't matter. So then, now from here, based on these last two steps, any guesses what this next step might be? Yep, just to keep it in the order that I had it, I'm going to say BE equals AC, but that's totally fine if you flip them. It's not one more right than the other. I'm just doing it to keep stuff in the same order that I have it. So BE equals AC. What allows me to do that? Where's the S?
Substitution.
Yep. I think I heard somebody else say it too. Substitution. Whoa, I just put way too many T's in there. Substitution. There we go. I think it might have actually been too many I's, not too many T's, but I can't spell, so I'm a math teacher. All right, so then if these are equal, what does that mean?
They're congruent.
They're congruent, first and foremost. We're getting to the triangle thing that I think was about to be said. So BE is congruent to AC. Same reason that we had up here, just in reverse. It's the definition of congruent segments. Now, there's one other thing in here that I have not addressed from the picture yet. So I've said now that this whole side here is congruent to this whole side here. I know that these are congruent, but I don't know anything about angles, so I can't do anything with angles. So to prove the triangles are congruent, my only options right now are side, 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 or side, angle, side. I know nothing about angles, so what do you think I might need to do? Okay, so side, side, side. So I've proven that two sides are congruent, so what else do I need to do? I'm looking at this big triangle here, and then this big triangle here. What do they have in common that hasn't been talked about yet?
A and BC.
Yep, BA equals AB or AB equals AB. It doesn't matter, however you want to write it. So we would say that AB is congruent to AB. Again, if you want it, sometimes the book flips the letters a second time, but it's the same thing. What allows me to say that?
Reflexive property.
Yep, reflexive property. So now, ultimately, then what can I say? I have proven now all this stuff to be true. So now what can I say?
Triangle ABC is congruent to triangle BAE.
Yep, triangle ABC is congruent to triangle VAE by what?
Side.
Side. I don't know anything about angles on this one. Alright, so I know that one was a lot. Again, steps 2 and 3 could have been flipped kind of in the order that I did them. But I would have had to have both of those before I technically end up continuing on. So, alright, any questions about those? Alright, so the problems that go with this. Again, don't forget we had done some stuff the other day. Review that if you need to. Go back. I'm pretty sure the video is posted. Watch the video. We're going to go with...
This is homework, right?
Yep. 7 through 15 odd. And then for some proofs, 21... 23. This one though, do a 2-column proof, not the paragraph proof that it says to do. And then 25. So those first ones are pretty quick and easy. You're just writing like what allows you to do them or whatever is congruent based on that. And then those last 3 are proofs that you need to do.